Welcome everyone. In this video we will solve a very interesting rotation problem. It's a physics Olympiad problem, a Turkish physics Olympiad problem. You can access the original exam paper from the descriptions part. Let me draw the picture and then give you some time to think about it. So we have a path like this. It looks like an ellipse, kind of a circle, but not really a circle. It looks like an ellipse. As I said, we have a mass here, a mass of m. Oops. Now, we're told the radius across this is 2r. And we're told this angle is theta. The angle in this radial direction, the angle between that radial direction and the horizontal is theta. And by the question, we're told that sine of theta equals 0.2. Alright? Now, the question asks us, when the object comes to the lowest point on the path, what will the normal force acting on the object be? What is the magnitude of n when the object is at its lowest point? And we want n in terms of mg. Okay, you can try the problem on your own. So pause the video. Alright, I assume that you're now ready to see the solution, to solve it together. The first thing that I want to do is to calculate the initial height of mass m. So this is h, the initial height. If I choose this dashed line to be the zero level, what will the height be? We have a right triangle, this is 90 degrees. So the hypotenuse is 2r, and this is the opposite side, so it is sine theta. This is the height. Cool? Now, so the energy will be conserved, there is no friction. Perhaps I should have told this before giving you some time to think about it. Sorry for that. So the friction is neglected. That means the energy is constant. So the energy at the top should equal the energy at the bottom. At the top, the mass is released, let's say. So there is no kinetic energy. There is only potential energy, which is in the form mg. The height, which is 2r sine theta. This should equal, at the bottom, since we chose the dashed line to be the horizontal zero level, there is no potential energy, there is only kinetic energy in the form 1/2 mv squared. And here we see that masses cancel. That happens a lot in energy calculations. So we see that v squared equals 4gr sine theta. And we are told what sine theta is. It is 0.2. So let's just substitute it. We're going to have 0.8 gr. And I'm not substituting for g. We want our answer to be in terms of g. And for r, well, we don't know the radius value. So that's it for energy calculation. Now, what else can we do to solve this problem? The other thing that we need to do is to focus on the lowest point and draw the forces, the free body diagram. Now, at that point, the gravity is, of course, going to be acting downwards for any point that is correct. And the normal force, we're not sure about its direction. I mean, it is going to have an upward component. That's kind of obvious. But since it will be a push by the surface, but what angle will it have with the horizontal? Will it be like this, or perhaps completely along the horizontal, completely along the radial direction? We don't know yet. One thing we know is that the centripetal force will be along the radius. So it will be along the radius like this. That is the direction of the centripetal force. And we know that the normal force plus the force of gravity should give us the centripetal force. The vector sum of the two forces gives the net force, which is the centripetal force. Alright? So, with that being said, now we're trying to understand the direction of the normal force. And you might already see, so we have normal force like this. Because we start at this point, we have mg, and from it we should have the normal force. Of course, that is just its projection. The actual force would be something like this. It is applied at that point. So, however, we will focus on this drawing. Let me draw it. We will have n, like we just argued. From it, we have mg downwards, and we will have the F cent, the centripetal force, Fc. We know the angle between Fc and the horizontal. It is theta, the same angle that is between the radial direction and the horizontal, because the centripetal force is radial. Now, I want to find this angle. What will it be? Well, notice that this part is 90 degrees minus theta. So this yellow and light blue should add up to 180 degrees, which shows us that the blue angle should be 90 degrees plus theta. Let me make theta prettier. Alright, plus theta. Now, how does this help us? There is something called the law of cosines. And the law of cosines, which I have a video about, I derived it. You can access that video from the cards right now and also from the descriptions part. That law tells us in a triangle, so in any triangle, A, B, C, this is theta, c squared is equal to a squared plus b squared minus 2ab cosine of theta. This is the law of cosines. Okay? Now we're about to use this. Let me erase it and use it for our forces. So we're trying to find n squared so that we can find n. It will be mg squared plus fc squared minus 2mg fc times cosine of the angle between them, which is 90 degrees plus theta. Alright? Now we can simplify this guy. It is going to be cosine 90 degrees times cosine theta minus sine 90 degrees times sine of theta. The first one goes to 0. We have then sine of 90 degrees is 1. So we have negative sine as the cosine of 90 degrees plus theta. So we in fact have mg squared plus fc squared plus 2mg fc sine theta. Notice that this negative and this negative gave us a plus. Alright, cool, but we now need F centripetal, the centripetal force. And it isn't that hard to figure out actually. So let's do it. We will have I don't know where to do it. I think we can fit it in this corner at that point. So the centripetal force is mv squared over r, because the centripetal acceleration is v squared over r. If we substitute for v squared, then we see that and this is capital R, the r's will cancel. I'm looking at this point, or at this point actually. So we get 0.8 mg. Alright, now we can substitute it. So I'm going to have mg squared plus 0.8 mg squared plus 2mg times 0.8 mg times the sine of theta, which is 0. There's no enough, there isn't space. let me try to fit it. So we have 2 and we have 0.8 from the centripetal. Mg will be squared and then we have sine theta. Okay? Now that part will give us then. Let's calculate it. So we will have mg squared, that's for sure. And what is the summation of the coefficients? We have 1 plus 0.8 squared, that is 0.64, plus 2 times 0.2, that is 0.4, 0.4 times 0.8, that is 0.32. So all of this gives us 1.94, which is, we have mg squared again, times 1.94 is 14 squared over 10 squared. Then if we take the square like this, here and here, we get the result that n is equal to 14 over 10, so 7 over 5 mg. Alright, this is our final result. I hope this video was helpful. If you have any questions, please write them in the comment section. I hope to see you in another video. Until then, take care.